Hello, Oshkosh North math students. We are going to take a look at AP Statistics Lesson 5.1, Day 2 today. And we're going to start with your notes. So please get your notes out. If we're going too fast, you can pause it. Last time I wrote the notes as we went and it went too slow, so I'm going to have them all ready for you. But if I'm going too fast, you can pause it and get your notes down. So Pepsi ran a promo contest for their 20-ounce bottles of soda. Some of the caps said, "Please try again," while others said, "You're a winner." Pepsi advertised the promotion with the slogan, "1 in 6 wins a prize." Mrs. Gallus's statistics class wonders if the company's claim is true. To find out, all 30 students in the class go to the store and each buys one 20-ounce bottle of soda. It turned out that 2 of the 30 students got caps that said, "You're a winner." So how many winners would we expect in this instance out of 30? Well, if we had 30 people and you have a 1/6 chance of being a winner, 30 times 1/6 is going to get us 5 winners. We are not guaranteed to get exactly 5 winners every time. It just means that statistically, over the course of time, doing this many, many times over, we are going to get about 5 winners per 30 entrants in the contest. Does this result give convincing evidence that the company's 1 in 6 claim is inaccurate? We will perform a simulation to help answer this question. We will assume Pepsi is telling the truth, that 1 in 6 wins. If they are telling the truth, what is the probability of getting 2 or fewer winners in a class of 30 purely by chance? So that's what we got to check out. You know what? We did it. We got 2 of our classmates got winners and the other 28 did not. So initially, I think we would be suspicious about this, but keep in mind, it's one trial. And in one trial, you really need a lot more than that to make any statistical decisions. So what can we use for a simulation? Because we don't want the students to go back and keep buying the soda. We want to do simulation with something mathematical to see what the chances are if we are, if we get 2 winners out of 30, is that statistically relevant? Well, let's say that we're going to roll a die, and if you get a 1, you're a winner. If you get a 2, 3, 4, 5, or 6, you're a loser. You're not really a loser. It just means that you get try again on your bottle cap. So we're going to roll our die, or our number cube, if we want to be politically correct, to imitate the process of the students in Mrs. Gallus' statistics class buying their sodas. How many of them won a prize? Okay, so we tried it again, we got 5. Then we did it again. We rolled the dice 30 times, and this time we got 6. And these answers would vary. If you were in class, we'd actually do this together in class to see. Well, we do it 50 times, and here's what happens. So those are your winners. It looks like the most that we had out of 30 was 11 winners over here, and the least that we had was 0 over here. Okay, Mrs. Gallus' class, that one time that we did it, we got 2, and we're trying to figure out if that is significant or not. So what we're going to do then, guys, is we're going to take that 5, which is out of 50. So this 1 plus these 4, so 5 times that we got either 2 or less, that's 10%. And so it's not going to be statistically significant. Okay, what we learned in our textbook was if it's less than or equal to 5%, it is statistically significant. In this case, it is not. It's 10%. It's close, but we could get 10% of the time. This could happen just by chance. So we're not going to argue their case that they're accurate about their 1 in 6 wins. It says, does it seem plausible that the company is telling the truth, but that the class just got unlucky? Or in other words, do we have convincing evidence that Pepsi is lying? No, we don't have convincing evidence that they're lying. there is a 10% chance of getting 2 or fewer winners in a class of 30 purely by chance. So that concludes the first page of our notes. Let's take a look at the important ideas for simulation. Simulation is what we're working on here in lesson 5.1. This is day 2 of your notes. The important ideas: simulation. It's imitation of chance behavior based on a model that accurately reflects the situation. So you could use dice, you could flip a coin, you can use an applet on a computer, you could use a random number generator. There's several different things that you can use that would randomly simulate a situation. In our case, for the Pepsi, we just randomly simulated it with a 6-sided number cube, and we did our trials. The simulation process, part of your notes, describe how you will simulate one trial or one repetition. Perform many trials or repetitions. Use the results to answer the question. All right, so this time we're going to be dealing with Wheel of Fortune. You've probably seen this game before. Some people have wondered if the Wheel of Fortune wheel is fair. If it is fair, the bankrupt result should occur with probability of 1/9. To test the wheel, Pat Sajak observed a random sample of 50 spins of the wheel and found that the bankrupt was spun 10 times. Is this convincing evidence that bankrupt comes up more than it should? So 10 out of 50 is what happened. Is that evidence that it's unfair? Well, we're gonna check it with a simulation. So describe how you would carry out simulation to estimate the probability that in a fair wheel, bankrupt comes up 10 or more times. So we're going to use a random number generator this time to get 50 integers between 1 and 9. We're going to let 1 equal bankrupt, and 2 through 9 are anything else. Because right now we don't care if it's $500 or $900 or whatever it is. We just are looking at bankrupt or not bankrupt. So you do this many, many times to estimate the probability of getting 10 or more bankrupts. Here's the dot display that we got from conducting this experiment. The dot plot displays the results of 100 simulated trials of 50 spins of a fair wheel. Okay? If in one simulation of 50 spins of the wheel, there were 12 bankrupts right here. That was the most. Okay, we got 10. So this was one of our dots right here. So let's figure out if that's significantly, if it's statistically significant. What conclusion would you draw about 10 or more bankrupt spins occurring in 50 spins? Okay, well, it's less than 5%. See, it was 4%. It happened 4 times out of 100 that it was 10 or more. That's less than 5%. So that does fulfill our stipulation for being statistically significant. Assuming the wheel is fair, there is about a 4% probability of getting 10 or more bankrupts in 50 spins just by chance. Because this is unlikely, we do have convincing evidence that we have an unfair wheel. So in this case, we would say that it is statistically significant, and we do have enough evidence to say it's an unfair wheel based on our simulation, which was right here. That concludes our lesson for today. Have a great day. See you next time.